The deep ocean is a place that is full of otherworldly creatures and fascinating processes. Life here is unique, as it must be in order to survive the immense pressure, darkness, and the extreme temperatures of the deep. But resting on the ocean floor, there is a secret world that seems as if it defies the laws of physics. Here, water that can be up to 5 times saltier than the surrounding ocean seeps out of the sea floor and flows into basins to form brine pools. These deep-sea lakes represent what appears to be, at first look, a dead zone of life, where any creatures to delve beneath the surface never return. And yet, around the perimeter of these brine pools, in stark contrast to the death traps they represent, there is an abundance of life to be found. Tiny amphipods dwell atop a mineral-rich, biologically diverse sea floor. Vast colonies of mussels stretch beyond the dim horizon, supported by the high concentration of methane gas that seeps out of these pools. The mussels are only able to survive here by depending on chemosynthetic bacteria that live within their gills, together forming a symbiotic association. The bacteria convert dissolved gases such as methane and hydrogen sulfide seeping from the ocean floor to make the energy needed for life, and so they are able to sustain both themselves and the mussels. By living within the gills of the shellfish, they are protected from the many predators that stalk the dark sea floor. A community of uniquely adapted organisms is able to thrive on the brine pool shore. In a similar fashion to the life that inhabits deep-sea hydrothermal vent communities, we find organisms capable of chemosynthesis, as well as other organisms preying on them, all interacting and existing on the borders of a toxic pool of brine. As the energy here is largely supplied by chemosynthesis rather than sunlight, brine pools also mirror hydrothermal vents in demonstrating how the extreme deep-sea ecosystem is unique in the ways in which it supports life. There are no photosynthesizing primary producers converting sunlight into energy, as the light of the sun cannot reach these depths. Instead, energy is supplied by the earth itself. Hagfish are frequent visitors to these briny shores, as well as crabs that risk their lives in order to feed on the bed of mussels. Some who visit are not as lucky as others. Sharks can be seen circling above the pools, opportunistic feeders who rely on these isolated pockets of life in the deep as a source of prey. Deep-sea brine pools form when water intrudes into ancient salt deposits under the seabed. The water dissolves some of their minerals and is forced out of the seafloor by warping and cracking of the salt plates, leaching up into the ocean. This highly salty water is denser than the surrounding water, so it flows into basins to form these lakes of brine that sit on the seabed. The Gulf of Mexico contains a large number of these, varying in size from 1 meter across up to 20 kilometers long. But the landscape here is characterized also by a series of strange ridges, slopes, and valleys, caused by salt tectonics and mineral deposition sculpting the overlying sedimentary structures. This encases the brine pools in mineral dams of their own creation. Brine pools certainly have earned their titles of pits of despair and hot tubs of death. There is a fine border between where life is able to thrive and where life seems altogether absent. This is because the brine itself is toxic to most sea creatures, for these deep lakes contain almost no oxygen and are far too saline for animals to survive in. When an organism enters a brine pool, they attempt to breathe the environment, subsequently experiencing toxic shock due to the hypersalinity. Often, any unfortunate animals to delve below the surface become pickled, as shown by how creatures have been recovered from the pools with soft tissue intact, despite having been dead for decades. However, as we continue to see in many extreme deep-sea ecosystems, life has found a way to survive even within these toxic salty lakes. Smaller organisms have evolved the ability to convert the methane into energy, supporting a community of bacteria, shrimp, and even tube worms. However, that's about as long as the list gets. The concentrated brine remains a deadly place for most creatures. In many deep ocean ecosystems, from whale-full communities to scalding hydrothermal vents and toxic brine pools, there is a pattern of life thriving in very close proximities to death. Whether organisms are deriving nutrients from sunken corpses that give life to the barren deep for centuries, or somehow finding a way to exist in the fine gradient between an energy-giving death trap and the lifeless sea floor, creatures of the deep sea are specialized, unique, and evoke a fascination for the peculiar wonders of the abyss.